Hello, good afternoon, everyone, for those who are based in Europe, and also good morning for those who are based in Brazil. My name is Rita Menezes. I'm from Trustworthy Services, which is a partner of Atmosphere project. So Atmosphere is a European and Brazilian funded project that is increasing trustworthiness on cloud computing. Today, we have our final webinar, and as speakers, we have our coordinators. From Europe, we have Ignacio Blanquer, which is European coordinator, as I said, from University of Valencia. And then we have Francisco Brasileiro, which is a Brazilian coordinator, and he is based in Campina Grande from Federal University of Campina Grande. Today's webinar, which is the final one from Atmosphere, is entitled Managing Trustworthy Big Data Applications in the Cloud with the Atmosphere platform. So this project is almost finishing. It's going to finish this month in October. And with this webinar, we want to showcase some of our final results, the results of the work we have been developing in the last 2 years that will help you to increase the trustworthiness levels of your cloud computing applications. Now I'm going to pass the floor to Ignacio and Francisco, who will start the presentation. Just a friendly reminder that if you have any questions, you can write them down on the chat, and they will be posted to both Ignacio and Francisco at a suitable moment. Ignacio and Francisco, the floor is yours. Good luck.
Okay, thank you very much, Rita, for your kind introduction to this webinar. So the way this webinar will take place is that we will share the presentation of the project. I will start presenting a bit the problem that we want to solve. Then Francisco Brasileiro will describe the infrastructure solution for that, and I will continue describing our complex use case and how the Atmosphere platform addresses these problems. So I hope that you can see my screen. So as Rita mentioned, Atmosphere was a project funded under the H2020 program by both European Union and the Ministry of Science and Technology in Brazil. So it's a type of project that has been very successful, putting together groups from Europe and Brazil to collaborate in common topics. So basically the objective of Atmosphere is to develop a federated cloud platform and to put on top of it a development framework for evaluation of the trustworthiness of the cloud services and application, and providing a layer for the data management and the data processing that increases the trustworthiness of the applications. In this sense, we demonstrate these features in one pilot use case, which is devoted to medical imaging processing. So starting for that, so that's the simple question, the simple problem, or trying to put in a tweet, let's say, what is needed by the developers of the use case. So developers state that they need to build up an image processing tools, an image processing framework that use sensitive data requiring a high computing demand. Once developed, I want to exploit it as a service securely and with quality of service. But I don't want to care about the infrastructure, resource management, job scheduling, secure access, and similar burdens. I don't want to have any sensitive data exposed. So Atmosphere tries to address these points in general. So the specific problem that we are addressing is related to medical data. Medical data is highly sensitive, so fits very well the problem. Also, let's say the needs of this trustworthy processing, and we focus on the diagnosis, early diagnosis of the rheumatic heart disease, which is a disease that if it is treated, if it is detected early and treated well, it will be very easily mitigated. However, if it remains untreated, it can have a very severe damage on the population. So for that, we get data from the PROVAR study, which is a retrospective trial that gathered information from several thousands of patients in the rural areas of Minas Gerais. So this data is sensitive data because it also has not only the part of the images, but some associated data, and we have to use with some, measures. So this basically we have this amount of data that has the richest part is the information that is coded in videos, and developing a system to have an early classification, an early detection, an early diagnosis of the disease is not trivial. It's not trivial because the images are basically echocardiograms. There's a lot of videos, on the order of 75,000 of videos, and it requires non-trivial skills that are normally outside of the hospital burden, right? Right. For this purpose, the people that were developing the use case imposed the following requirements. The sensitive data must not be accessible out of the boundaries of the hosting countries. There are registration legislation with respect to the personal data in Brazil, and we have to guarantee that this data doesn't come out. However, anonymous data could be exchanged, could be used, but also it shouldn't be accessed publicly from outside. It should be released under a specific condition. Second is we will use machine learning and artificial intelligence techniques for creating the classifiers. For this purpose, we need computing resources that were not available on the centers of our, on the consortium on the Brazilian side. However, this is actually more a proposal rather than we for sure could find those resources in Brazil, but we have to demonstrate that this system is viable for a geographically wide cooperation. Moreover, at the European side, we have an expert group, expert company on the processing of medical imaging and developing biomarkers, and they will be the ones that will analyze the data. And finally, the experiment should be reproducible and stable. Whatever we develop should be easy to deploy, redeploy, and rerun without, requiring a minimal manual intervention. With this in place, there appears an important concept, which is trust. Trust is a choice that is based on the experience. So we have to build trust based on a long period of demonstrating that we have the ability to provide the results in the way that we are expected. Trust can also disappear very quickly. It takes a lot to build, but it can take a very few time to disappear. Trust in cloud services is as complicated as trust in people, and we have to rely on multiple dimensions. We have to rely on things like the privacy, security, coherency, isolation, and other more complex properties like the fairness, transparency, and dependability. So there are a few efforts on quantifying trust on cloud computing. Right? Even if we go to the problem of artificial intelligence models and algorithms, we have more complex trustworthiness properties that are from the traditional dependability studies, which are the fairness and the explainability. The fairness is how is the bias of your model affecting your results, and the explainability is how can you guess which were the key points or the key information that drive to a specific decision by the models. Finally, the evaluating the privacy risk, because every time that you expose data, you have a privacy loss risk. It's important. If you build a model and you use personal data, or even if you don't release the personal data, you have some privacy leaked inside the model, so you have to provide quantitative measures. So there were, let's say, the high-level requirements for the developers. With this in place, we have this situation. We have end users, which are data providers and data scientists that need for secure transfer, data access tracing, and they don't have to worry about ICT skills. We have application developers that develop tools for processing the data, And they require an infrastructure that can be secure, highly available, and with persistence of data, covering international and intercontinental cooperations. They will deliver the application to others to operate. And we have the application managers who are the ones that put the applications in place. I would like to concentrate on managing the application without having to deal with a specific management of the trustworthiness of the services should be the optimal. And then with this concept comes the Atmosphere platform that will be presented by my colleague Francisco Brasileiro.
Thanks, Ignacio. So Ignacio has set the problem, and what I'm going to do now is to describe what was the approach of the project to provide solutions for these problems. And the idea is to propose this this platform that people can instantiate to build this federated infrastructure and use several services to help them developing and deploying and managing their application. Next slide, please. So before detailing the several services that have been developed, it's important to have a more conceptual understanding of the platform. And I'm going to talk about 4 different dimensions of the platform. Next, please. So first of all, let us talk about the users and their roles. We envision 5 roles for the users that will interact with the platform. We have application developers and data scientists. These are the people that will use the services in the infrastructure or embed services in their applications. So to develop these applications that obey or provide some trustworthiness guarantees for the users and the data owners. A data scientist is a special kind of application developer that not necessarily has does not necessarily have computing science skills. So he or she will need to interact with a higher level programming to develop machine learning models for the big data applications. The application manager is the person in charge of taking care of the application once the application is deployed. So its role starts by deploying the application, but the application manager also needs to monitor the execution of the application throughout its lifetime in order to assess whether or not the application is attending the requirements. A 4th role is the one of the system administrator. It's the role of the system administrator has to do with the infrastructure level services. So making sure that the infrastructure is connected in a secure way, that resources can be instantiated anywhere in the platform, and all the infrastructure services are working appropriately. And finally, there is the data owner that is responsible for defining the policies that need to be enforced in data access. Next, please. The services that are provided by the Atmosphere platform, they come in 2 flavors. So for each particular deployment of the Atmosphere platform, you will have federation-wide services that can be used by users and applications anywhere in the federation. So whichever application or user that can access the platform will be able to use those services. And also there are services toolboxes with applications or engines that can be embedded in the applications, in the trustworthy applications that are developed and deployed on top of the platform. Next, please. Those services, they are divided, they can be divided according to the layer where they sit. So on top we have the application, on the bottom we have the federation infrastructure, and everything in the middle are the services that are provided by the platform. So on the top layer in green, we have service for trustworthy data processing. And here we have a special interest in big data applications. So here is where we provide support for those trustworthiness properties that Ignacio mentioned before, that are related with the machine learning models that are embedded in the application. Things like fairness, stability, explainability, transparency, etc. On the yellow box, we have the trustworthy data management services. These are in charge of providing secure and private access to the data that's manipulated by the applications on the top layers. And on the bottom in blue, we have the infrastructure management services. These are in place to facilitate the deployment in this not trivial infrastructure with cloud providers, multiple cloud providers, and the need to deploy resources in these different cloud providers that need to communicate with each other in a secure way and private way. Across all these layers, we have the TMA layer, which is in charge of assessing and monitoring the trustworthiness of the application. So this is done in all levels of the infrastructure to make sure that you can have a quantitative measurement of the trustworthiness that is delivered both at design and at execution time. Next. Right, so talking about the application life cycle, as I mentioned before, that is the design time and the execution time. So at design time, the application developer will build the application and then use the TMI services to assess the trustworthiness of the application, and if it's the level is not required, it's not at the required one, then the developer would iterate in this loop until the trustworthiness is at the required level, and then the application can be deployed. And then we start a second level of assessment and monitoring of the trustworthiness that uses a MAPK approach to monitor at execution time the trustworthiness level of the application. We'll analyze if there is any intervention that needs to be made, and if this is the case, plan this intervention and execute it so that the application will move back to an envelope where its trustworthiness properties are enforced. Next, please. Now I'm going to talk about the specific services that have been developed, and I will do that on following this layered structure. Next, please. Right. So this is the first layer is the TMA layer, as I mentioned before, this is implemented by a classic MapK approach. So the yellow box is the managed system. You deploy at the managed system probes that will collect data about the important metrics of the application. These metrics are fed to the analyzed module, which incorporate quality models that are used to compute a score for the trustworthiness of the application. And these scores are then fed to rules that will identify when the application needs to be adapted. And if this is the case, then there are actuators deployed together with the application that are invoked by the TMA services, so that the application will change its behavior and hopefully will get the application back to where it should be. Next, please. So at the TDPS layer, the main tool there is called Lemonade. Lemonade is a web-based system for designing and running analytics applications. So as I mentioned before, part of our users are people that not necessarily have programming skills. So we are providing them with a graphical tool where the workflows can be coded as a drawing the workflow that should be executed. And Lemonade is in charge to generate the code that will provide the application that runs the design workflow, and also deploy it in the infrastructure. The deployment in the infrastructure is done with the support of the other services in the infrastructure management layer. The workflows consist of boxes and arrows that represent data preparation and engineering, machine learning methods, and visualization metaphors. And in the next slide, I discussed the main properties, trustworthiness properties that are supported by Lemonade. So Lemonade provides features that allow stability, privacy, transparency, and fairness to be tackled. For instance, using cross-validation for stability, and then in this interactive environment that Lemonades offer, data science can use this to calibrate the model. Also, there is support for transparency, for explaining what decisions this model, how the model takes particular decisions, and also fairness enhancing mechanism. All these can be used in an iterative way using Lemonade. And Lemonade has also the ability to export a trained model into an engine that can later be embedded in a standalone application that can be later deployed in the infrastructure. Next, please. There is at this level we have also the privacy assessment forms, which is a tool that helps organizations to understand what are the data that their applications manipulate that might be affected by regulations such as GDPR and LGPD. And these assessments, this tool provides reports, and these reports can later be used to feed security and privacy policies that can be used by other services, for instance, by Lemonade. Next, please. At the trustworthy data management layer, the problem that we have there is, so the current situation is that people encrypt data in transit and at rest. Some of the processing can even be done over the encrypted data using techniques that allow the encrypted data to be processed without the need to have it unencrypted beforehand. And keys and certificates are not included in the repositories. This is the current approach to deal with security and privacy. However, this is not enough because attackers may have access to the machine. Code can be changed, memory can be dumped. You can have, you need to trust your provider, and not only your provider, but your provider's employee, which keys can be stolen, for instance, by a newly intended employee. So in the Atmosphere project, we took a different approach. Next, please.
Nope.
So the idea is to use trusted execution environments, such as Intel's SGX, to protect data access using the cryptography support given by these trusted execution environments. So the advantages are that raw data is preserved. So we keep data does not need to be encrypted or anonymized where it's studied. And we use proxies to do to filter queries that are sent to the data repositories, and on the results that are returned from these queries in such a way that we protect sensitive data. So data is encrypted not only in transit and at rest, but also during process. And using trusted execution environments, we can also enforce that only specific applications can access the data. So in a graphical way to visualize what I just said, we have the Valon framework, which is our implementation of this data protection layer. So what it does, it intercepts all the queries that are sent to either the relational database or the file system or the object store databases, and do query, modify the query so that security and privacy policies are enforced, and in the same way modify the result in such a way that the result is compliant. For instance, I can execute anonymization before returning the data to the invocation, to the client that invoked the service. Next, please. Finally, we get to the infrastructure management layer. There is a set of tools that have been developed to help deploying applications in this infrastructure. In the bottom layer, we have Fogball. Fogball is a middleware that's used to federate cloud providers. It allows any instance of Fogball allows their clients to instantiate resources in any of the resource providers that belong to the federation. And it also provides the ability to create private federated networks, in the sense that you can instantiate resources in different data providers, in different administrative domains, that will see each other as if they belong to the same private network with all the security and privacy guarantees that this kind of networking allows. On top of that, we deploy a federation-wide TMA. So the TMA that I mentioned before that can be embedded in the application. We also have a centralized TMA service that is in place essentially to make sure that the dependability, trustworthiness guarantees, properties of the infrastructure are guaranteed. On top of that, we have two tools used to deploy Kubernetes clusters using Tosca recipes. So EC3 and Tosca IM are combined together to provide this facility. And finally, we have a tool that allows the performance prediction of the models that execute the big data applications, so that to facilitate the allocation, the capacity planning of the applications that is done by the application manager. So essentially, this is what the platform offers. And in the following, Ignacio is going to give an idea how we have used these services to address the particular problem that we use as an example case and motivation case throughout the project.
Thank you very much, Francisco, for the explanation. So I will continue with this instantiation, this example. So basically, the idea is the following. We have data in Brazil, securely stored in an encrypted way. We have resources that can run this trusted execution environment, SGX, Intel SGX extensions in Brazil. And we have in Europe, on the right side, we have GPU-enabled resources, right? So the idea will be to use the Atmosphere platform to manage this, this distributed and federated environment. Right, first, deploying the infrastructure. So for deploying our virtual infrastructure, we use these Tosca descriptions that has all the information required for deploy a Kubernetes cluster with self elasticity rules. So we have a dashboard that developed to ease this process. So you will go to the dashboard, you will have your own Fogbo credentials, and through that you will instantiate this cluster. This cluster will create a virtual federated network and will run across multiple sites in both continents. So the nodes of the Kubernetes cluster will be spawned across the virtual network in both continents. So the nodes, when you deploy a component that requires SGX, it will go directly to the resources, the nodes that provide this extension. And if you require a GPU, you have a pod or an application requiring a GPU, it will go to the specific, automatically to the specific resources. Also, this Kubernetes is self-managed, and it will not spawn the resources if there is no workload that requires this. So once that you go there and you, deploy this Kubernetes cluster, the next point will be to deploy the applications for store the data. So the data will be stored on a persistent volume on the Brazilian side and encrypted in memory. For that, we use Valum, as was commented by Francisco, provides us the capability of discriminating the sensitive data from the anonymized data. In this system, depending on the profile of the user, you will get different types of information. For example, names, surnames, population where city where the person was located, birth date. This information is not accessible. It's available on the database, but if you query, you will get anonymized data. It will be anonymized on the server side and automatically depending on the profile. You will have not only anonymization but also blurring. If you query for a record, it will give you not the city but the region, not the birthday but the year. So this information is the information needed for creating the models. The decryption and processing of the data is performed securely encrypted in memory, let's say. So then the data is transferred. So we transfer all the data, all the anonymized data to the European side where we have our storage attached to the GPUs. So we don't have to expose this data, anonymized data in a public endpoint, but we use the federated private network to guarantee that the communication is performed in a secure way. So once we have the data on the right side, on the European side, the expert developed the pipelines for the processing. The expert in Europe analyze the data and develop a pipeline for the identification of the rightmost information, in this case, a specific set of views from the echocardio images, segmentation, texture analysis, velocity extraction through the Doppler information, and create the features for the classifier. Then these features are the ones that were used to train the classifiers. So along with the the Python code for the pipeline, the expert on the project also helped on coding a pipeline on this Lemonade system. Lemonade will automatically generate the code for running the application, and also will be very easy to share, to understand, and also to get automatically the trustworthiness properties on biases and explainability, for example. Once that we have everything, we can run and get these reports. For example, for the fairness, the system uses the Atmosphere platform uses a component that is called Equitas. It's a third-party component developed at the University of Chicago that provides some information about the equal parity, proportional parity, and different rates that gives an accuracy, different ways of, different values of the accuracy depending on the data set. So then you could have information on how accurate is the system. You consider only male or female, and then be able to understand that the system could discriminate people according to sensitive data. So it will lead to rethinking on the data, creating better the data, enriching the data, or changing details on the model. The other important high-level feature that provides the Lemonade platform is the explainability, the interpretability, because despite that in medical doctors feel quite confident when you provide results coming from a black box, sometimes for the question of for the sake of the liability, it's good to have better inside information of why the machine learning model is providing a specific result or another. So which areas in the images are the most relevant for a specific classification. So we use for this for this purpose Lime and Sigma interpretability that are coded inside the system to give you an information. This information is validated by humans, right? So it gives a report on what were the key values used from the image data for taking the decision, and the medical doctors validate this, saying that this model has, let's say, some basic sense inside the decision, or basically require a retraining in order to find more based results. Finally, and also as was commented by Fubika before, we're using the privacy assessment form, PAF tool, that is both prepared to track data, annotate and track data with respect to the GDPR and the Brazilian LGDP, which is the equivalent law from the Brazilian side. Allows the user to annotate properly the key data that is sensitive. So the data owners can define the policies for preventing users that are not authorized to access sensitive data to do it, right? So this is a system that helps on defining these policies. So as the last point with respect to the let's say the trustworthiness properties related with the privacy and the security, we have the identification risk. So in some cases, this information is normally provided as in a qualitative way. So, but we incorporate in the different components of volume and Lemonade, we incorporate metrics for the re-identification risk and the information loss, which are based on the relevance and uniqueness of the records that you have after the anonymization. In this way, you can define a threshold. You can say, I want an anonymity that is of level 3. So it means that there will be no way to differentiate at least one record from the other 2. And the system adjusts the anonymization process to this specific policy. So it's very tailored for a quantitative anonymization process to guarantee that you have some comparable information on your data sets. So to end, what we wanted to address is this solution, is this this evolution. So from the need of manually configuring the environment with a low reproducibility and a qualitative appraisal of the trustworthiness to have a system that have application templates for complex and distributed application that can be repeatedly deployed and run with a quantitative estimation of the trustworthiness. Along with this, we have these high level metrics and properties on trustworthiness, like the managing of the of the biases and all the anonymization in a quantitative way, and providing this ability to run even in a secure way, even if the resources are not trusted. If you don't trust the cloud administrator, you can even run on encrypted in memory. So even with root privileges, you cannot access the data. And I think that was all from the webinar, and we will be happy to take questions now.
Hi, Ignacio and Felipe. Thank you very much for your time and for this very nice presentation about the atmosphere work that has been developed thanks to international cooperation between Europe and Brazil. Regarding the questions, I think we have one question from one of our attendees, which is, did you evaluate SGX overhead? What is run within SGX enclave? Not sure who would like to reply to this question, if it's Ignacio or Felipe.
I can take this partially because as application developer, I use Valium to access this part. Of course, there's an overhead there, right? So the point is that there's an overhead, not only because you run encrypted in memory, because the resources that are available inside the SGX are limited. I mean, they are increasing in different newer versions, but are limited, so it requires some memory. How to say? It's like scratching, let's say, in memory from the secure memory to the encrypted memory. We have this published on a paper that was recently accepted for the IEEE Cloud conference, in which we have a detailed experiment. So if you use, let's say,
I think it was actually CloudCom.
Oh yeah, sorry.
It's CloudCom.
Yeah, sorry. So basically, this is manageable for databases, right? So if you want to use for querying some information and then training the models, if you want to use in a transactional system for a highly rate, it will be an important I mean, overhead. But I think that you can go to the website, our website, and get this article that I believe that it will address better the questions.
Thanks, Ignacio.
It's important to say that all depends on the memory footprint of the application, and that as these trusted execution environments are becoming more popular, and the requirements on security are becoming more strong, it's likely that the hardware will keep the pace and will increase the protected memory that's available. So the horizon is, I would say, promising for this kind of technology.
Okay, I see. And now, during when you were replying to the first question, the same person made the second one, which is more related to Lemonade. So the question is, which underlying languages does Lemonade support?
Mm-hmm. Okay, so I take first. Basically, Lemonade uses boxes that are defined in either Spark or Python. I mean, you don't mix them, but you can work with Spark code or Python code. The last version, I mean, it's because Lemonade was started in a previous project collaboration. It was focused more on Spark. In the version that we have advanced more in the project, uses Python and has many libraries related to Python available, and you can deploy your own, develop your own boxes as Python with your Python code to be inserted in the system. But you can even do not use a single line of code and produce a Python code at the end.
Okay, thank you very much, Ignacio. Let's give a couple of moments for our attendees to submit any more questions if they want. And in the meantime, I would like to announce that if, like, for example, Ignacio mentioned that there's a paper, or there will be a paper focused on what was presented today. So all the papers that were, almost all the papers that were prepared by Atmosphere, they are available on the website under the scientific papers section. And if you are around Coimbra in Portugal, there will be the final session of Atmosphere at the IEEE Cloud Net event. There'll be a session there of 2 hours. I pasted the link on the chat. So if you are planning to go to the event, we'll welcome you to visit us there. Another thing is, the Lemonade that was presented here at the webinar, and also other assets available by Atmosphere, we have a service section on the website, so all the information is easily available there. We have demos, we have use cases, so if you want to know more, just visit us online, and if you have any more questions, just contact us by sending us an email. And we have another question that was submitted in the meantime. So the question is, it's also from the same person, which is, are implemented also auto recovery mechanisms at the infrastructure level in a case of a node fail?
Could you repeat that?
So the question is, are you implementing also auto recovery mechanisms at the infrastructure level in case a node fail? Is this clear?
Yeah.
Is the question clear for you?
Yeah, yeah.
Yeah. I can take the first part. I mean, from our application side. So what we have is this, I mean, Kubernetes cluster deployed on top of the infrastructure with this automatic elasticity system. So it happens sometimes that some nodes become unavailable, I mean, because there were some stress on the processing or some network issues. And what it produces is that the resources Kubernetes tries is a very good system for high availability. So it tries again to redeploy if it detects that it's not working. And if the node is not available, the system will finally deploy a new one. So let's say that the high availability is more provided through Kubernetes, and the infrastructure reacts properly to give more resources on demand.
And most of the servers are deployed on top of Kubernetes cluster, so they inherit this from the Kubernetes system. For instance, the TMA service that runs for the whole infrastructure, it runs on a Kubernetes cluster. So answer the question, we do not provide directly any support for this kind of things, but the service and incorporate this from other tools that already implement them.
Okay, thank you, Ignacio and Fubika. I think we don't have, let me double check. I think we don't have any more questions. So I would like to thank you for your time to doing this presentation. I also like to thank the audience for joining us. The PowerPoint, the webinar presentation will be available on Atmosphere website under the webinar page, and also this webinar video is going to be available there for your benefit to rewatch it later on. Thank you very much. If you want to have any more info, just drop us an email by visiting our website. Thank you very much, all of you, and see you soon. Thanks, Ignacio and Felipe, once again, for the very interesting presentation.
Thanks, Rita, for managing this. Thanks to the audience for listening.
Thank you. Bye.
Bye.